Right, year 11, I'm going to pick up from where I left off. I was up to question 18, exercise 10.5. If I look at question 18, x squared plus px plus 3 equals 0. Now the first one, 18a, the roots are equal. Now I can do this without doing any of the product and sum, because I know if the roots are equal, it's a double root, and if the roots are equal, the discriminant will equal 0. And the discriminant is b squared, well that's going to be p, minus 4 times a, that's 1, times c, 3, and that's got to equal 0. So you get p squared minus 12 equals 0. Therefore p squared equals 12. Therefore p will equal plus or minus the square root of 12. And I know that the square root of 12 is the square root of 4 times the square root of 3, which is 2 root 3. So equals plus or minus 2 root 3. I'm going to jump straight into b, because b follows on pretty much from this, because it says the roots are real. Well, that means the discriminant has got to be greater than or equal to 0. Now, I've already solved this. I've already found where this is. So it's p squared minus 12 has got to be greater than, because that's a discriminant, or equal to 0. Now, I've already found the 2 points. It's plus or minus 2 root 3. And we know this is a parabola. So the solutions are minus 2 root 3 or positive 2 root 3. And we know that when we write it like this, it's a positive parabola. Look at this, it's a positive parabola. This is a positive parabola here. And we need the parts where it's above the x-axis. So we need the parts p such that p is less than or equal to negative 2 root 3 and p is greater than or equal to 2 root 3. Now the last bit of this question, C. So C, one root is double the other. So here we'll use our product and sum. We'll let the roots be alpha and 2 alpha. So therefore the product of the roots equal will be alpha. Try and make this tidy. Alpha times 2 alpha, and that equals C on A. And if I look back, C is 3 and A is 1, so that equals 3. Therefore, 2 alpha squared equals 3. Therefore, alpha squared equals 3 on 2. Therefore, alpha equals plus or minus root 3 on root 2. Now, the sum of the roots, well, that equals alpha plus 2 alpha, which equals 3 alpha. Oh, hold on. And if I look up here, that's going to be P on 1. So 3 alpha equals P. Well, we know what alpha is, so therefore P equals plus or minus 3 root 3 over 2, and it's plus or minus. Oh, sorry, root 3 over root 2. So that's question 18. Now, let's have a look at question 19. And maybe you can do 20 on your own. So I'll just get rid of this so we can see the question at the same time. All right, question 19. What do we got here? Find the values of k. So let's write the equation for 19. What do we got? X squared plus kx plus k minus 1 equals 0. Now, the first one, the roots are equal. Well, let's just use the discriminant for that. If the roots are equal in A, discriminant has got to equal 0, which gives me b squared, that's the k squared, minus 4 times the 1 times c, 4ac. Now remember c is k minus 1, so I'll put it in brackets. And that's got to equal 0. Now, I'll get k squared minus 4k plus 4, which equals 0. Now, I should have realised that. Oh, no, we'll go on. So, that is k. Oh, hold on. I see that that's a perfect square. And that gives me k minus 2 all squared equals 0. And that means k will equal 2. There's our first one done. The next one of the roots is 4. Well, again, let's not do more work than we have to. If we know that one of the roots is 4, well, we'll let x equal 4 and solve it. So we get 4 squared minus plus 4k plus k minus 1 equals 0. That'll give me 16 plus 5k minus 1 equals 0. It gives me 5k plus 15 equals 0. 5k equals negative 15. K equals negative 3. Well, that was pretty easy as well. The last one, C. The roots are reciprocals of each other. All right, so if the roots are reciprocal, we'll let the roots be alpha and 1 on alpha. Now, as soon as I see reciprocal, I know that I want to go for the product. So the product of the roots will be alpha times 1 on alpha, and that equals C on A. So we go back to our equation, and that's K minus 1 on 1. K minus 1 on 1. And alpha times 1 on alpha is 1, equals K minus 1 on 1. So 1 equals K minus 1. 2 equals K. So question 19 was pretty easy. Question 20, I want you to have a go at, but I will do 20B because we get a third answer. And I want to make sure that you can see how that works, because I'm pretty sure we might have to use the quadratic formula. Might be wrong, but let's have a look at it. So, for question 20, let's write the equation. And what have we got? mx squared plus x plus m minus 2 equals 0. Well, I will do A. It's pretty easy. If one of the roots is negative 2, I'm going to put it in there. So let x equal negative 2. And that'll make it equal 0. So I get m times negative 2 squared plus negative 2 plus m minus 2 equals 0. 4m minus 2 is going to be minus 4, but I'm going to have that plus m minus 4. And that doesn't look right. That's because I've written minus 2 and it needs to be minus 3. So over here, let's get rid of that. And that'll be minus 5 equals 0. Gives me 5m equals 5 and m equals 1. Okay, let's move to the next one. It has no real roots. If it has no real roots, the discriminant is less than 0. So here we go. B squared. Well, B squared is 1. 1 squared minus 4 times A, and the A is an M, times C. And I'll put this in brackets, M minus 3. And that's got to be less than 0. So we're going to get a quadratic. I'm going to get 1 minus 4m squared plus 12m. It's less than 0. Now, when you get a negative x squared or a negative in front of your coefficient of whatever is squared in your quadratic equation, and this is a quadratic inequality, you can try and solve it on the left-hand side, but I'm just going to take everything over to the right-hand side. So I'm going to take all these things over. So I'm going to take the 12m over, I'm going to take the 4m squared over, I'm going to take the 1 over, and I'm going to, because I'm taking them over, it will change the sign. So I'll be left with 0 here. The inequality stays the same. I'll take the 4m squared over first, and that becomes positive 4m squared. Then the 12m, and that becomes negative 12m. And I'll take the 1 over, and that becomes minus 1. Now, that's the same as multiplying by negative 1 and change the inequality sign. So now we've got a positive parabola. We want the parts above, so we're going to find the critical points. We know we're going to have to find something that multiplies out to negative 4 and adds up to 12. And I don't know what that is. So I'm going to b squared minus 4ac. I'm going to have to invoke the quadratic formula here. So I'm just going to go to a different color so we can see what I'm doing. So I'm going to go blue. So I'm just going to solve this one over here. So let's go. M, the critical points are going to be minus b, so minus 12, so it becomes plus 12, plus or minus the square root of b squared minus 4ac. Well, b squared is 144 minus 4 times 4 times negative 1, all over 2 times 4. Well, that'll be 12 plus or minus, well, 144 plus 16 is going to be 160 over 8. And I'm going to get 12 plus or minus, I'm going to take the 16 out of that, root 16 over times root 10 over 8. And I'm going to take the 4 out of all of these things. So 4 times 3 is 12, plus or minus 4 times 10, all over 4 times 2. And now I can cancel the 4s. So I get the critical points are 3 plus or minus root 10 over 2. Now that we know that, they're the critical points, let's go back and have a look at this. So this is going to be a positive parabola, and the roots are at 3 minus. So over here we've got 3 minus root 10 over 2. And on the other side we've got 3 plus root 10 over 2. And it's a, look up here, it's a positive parabola when we look at that last line there. And we need the parts above. So now remember, the discriminant has to be less than 0, so it can't be equal to. So m must be less than 3 minus root 10 over 2, or m must be greater than 3 plus root 10 over 2. That's pretty messy. I'll check my answers, I'm pretty sure. Yep, that's it. Now, I'm going to let you have a go at 20 on your own. You see how you go.